Hello, everybody. In this video, we're going to be going over ants and SomeBees, which is the first question on the midterm review worksheet. This is a dynamic method selection question. So as a bit of a recap, let's go over what the important kinds of dynamic method selection questions are going to be. The first kind is what I like to call an assignment versus initialization question, which is generally going to take the form of this: class 1 n equals new class 2. This has two basic steps, right? The first step is everything left of the equal sign, which is initialization. We have initialized n, and during initialization, we set our static type. In this case, n has a static type of class 1. The right-hand side of the equal sign is the assignment. We are assigning this object to the variable name n, right? And in this case, the right of the equal sign is going to give us our dynamic type. Our dynamic type is granted during assignment. And the names of these types kind of gives us a clue as to what their function is. A static type is static. It never ever changes. But a dynamic type is capable of changing because we can assign other objects to the variable name of n. All right. The main knowledge check that they're going to look for is specifically this. This statement will cause a compile error if the dynamic type is not a static type. And this class 1 n equals new class 2 will cause an error if class 2 is not a static type. What does that mean? Well, in more rigorous terms, we say that class 2 has to have an is-a relationship with a class 1. An example of this would be squares and rectangles, all right? So every single square is a rectangle, right? So we would say that a square has an is-a relationship with a rectangle. If we see a square, we can also say it is a rectangle. It is a rectangle, right? However, an is-a relationship is not a two-way street because the rectangles are not squares, right? So if we saw a rectangle, we can not also confidently say that that was a square, right? And basically, in this specific example, if our class 2 was a square and class 1 was a rectangle, then we'd say that this line of code is valid because our dynamic type has an is-a relationship with our static type. Right? And generally in code, the way that we see is-a relationships expressed is through this line specifically. When we define our class, we're going to extend class 1. And what this is telling us is that a class 2 has an is-a relationship with a class 1. Now, once again, this is not a two-way street. So just because class 2 extends class 1 is not a class 2. This is only one way. All right, the other kind of question they'll be asking is well, I like to call method choosing. And method choosing kind of breaks down into two steps that has this like flow chart to it, right? The first part is compile time. So during compile time, we're going to try and define whatever method we called in the static type of the object that we're calling the method from. If the method is not found, then we're going to run, and then we're going to have a compile time error. If the method is found, we're going to move into runtime. Now, one key, very important note is that the method that you find in the compile time has to be equivalent in every way to the method we're trying to run. So that doesn't only mean the method name, but it also means specifically the method parameters. And if they're going to try to trick you on the test in this kind of question, this is where they're going to try to trick you on, okay? You have to make sure that the parameters that we're calling in are all the same. They have to be the same number of parameters. They have to be the same types of parameters. They have to be in the same order, okay? If they're not the same, you have not found a valid function, and you should have a compile time error. However, if you do find a function that matches all that criteria, we're going to move into runtime. Runtime is when we actually run the function. And what we do here is we're going to check to see if there's an overriding method in the dynamic type of the object. And what this means is that we're just trying to find a method in the dynamic type that, once again, method matches the method we're trying to run in name, in parameters, in order parameters. All right. If a method is found, we're going to use the overriding method. But if it is not found, we already have a method that works, which we found before, which is a static type, the method in the static type. So we're going to use that method instead. All right. And one last thing that they can do to try to trip us up is casting. Casting changes our method choosing in three main ways, right? So first of all, in compile time, instead of trying to find the method in the static type, we're going to instead find it in the method and then the cast type instead. All right, and all the same rules apply. It has to have the same parameter name. It has to have the same parameters. It has to have the same method name, right? If that is found, we're going to move into the runtime. And in the runtime, we have two different steps. First of all, we're having a new step, which is that we have to check to see if the cast is valid. And what that means is that the cast has to have a dynamic, is-a relationship with the dynamic type of the object. Otherwise, the cast is invalid. And if it is invalid, we're going to have a runtime error. Then, if that is satisfied, we're going to move on to the regular overriding function, where we're trying to find an overriding method in the dynamic type. But if it's not found, we're going to use the method in the cast type instead, not the static type. All right, now let's do an example question, question 1. So first of all, let's take a moment to look at our code, right? We have a class called insect that has two methods, stay that takes no parameters and speak that takes no parameters. Then we have two different classes, class ant extends insect. So class ant has an is a relationship with an insect. Then it overrides a speak method, which is the exact same method signature, and it also has a function attack that takes no parameters. Then B also extends its insect, so there is an is a relationship once again. It also overrides speak, and it has a new method called move that takes no parameters, right? And so the first step is this, right? So this is an assignment versus initialization question, and it's going to ask us what happens when we run this code. Well, first of all, we're going to check to see if the static type has an if the dynamic type has an is a relation with the static type. The dynamic type is insect, the static type is insect. These obviously have an is a relationship because they are the exact same class. And so therefore this line runs without problem. Next line is I.speak. So let's once again go over this very formulaically so we know how to apply this approach as we go forward, right? I.speak is first going to check it's first going to go in compile time. And in compile time, we're going to check the static type first. The static type, as we determined earlier, is insect. So we're going to go into the insect class. We're going to try to find a method called speak that takes no parameters. There is a method called speak that takes no parameters. And so therefore we have passed compile time. Now we're in runtime. In runtime, we're going to go to the dynamic type and check to see if there's an overriding method, or basically any method that matches the exact same thing. All right. So the dynamic type is insect. We're going to go to the insect class. We see that there is a method called speak that takes no parameters, and we're going to run that method. And so therefore, we're going to print I am an insect. All right. This has a very similar process for these next two questions, right? Ant A equals new ant. Well, we want to see if the dynamic type has an is relation with a static type. There is. So we're going to run A.speak. Once again, first, compile time. We're going to check the static type to see if speak exists. Ant does have a speak method, so that works. We're going to move into runtime. We're going to check to see if the dynamic type has its same method. There is. So we're going to run the method in the dynamic type, which is going to print I am an ant. All right. Now that we kind of understand the process, just really quickly do like a check on your knowledge and try to do these next two lines. All right, well, B equals new B obviously works because the dynamic type is the exact same as the static type, so this line runs without any problem. Then B.speak is going to check the static type, which is B. It does have a speak function. It's going to go to the dynamic type, try to see if there's a speak function. There is a speak function, so we're going to print I am a B. All right. All right, now this is where it gets a bit more complicated. I equals new ant. All right, and once again, this is an assignment versus initialization question. And now the static type and dynamic type are actually different, so we need to test ourselves. Remember, we are trying to see if the dynamic type has an is a relationship with the static type. The dynamic type now is ant. The static type, as we assigned before, is insect. Does ant have an is a relationship with an insect? The answer is yes, because ant extends insect. And so therefore, this line will run without any problems. Then we're going to do I.speak. All right, and now it's complicated because once again, I has a different static type and a dynamic type. I.speak, first of all, in compile time is going to go to the static type. Static type is insect, it finds a speak function. That's perfect. So we pass compile time. Now we're in runtime. Runtime, we're going to go to the dynamic type, which is ant. We're going to try to find a function called speak. We do find a function called speak. So we're going to use this function instead. We're not going to use the function that we found in the static type. So instead, we're using this function right here. We're going to print I am an ant. All right. And now I.attack. Try to solve this one for yourself because this is probably the most complicated one we've seen so far. All right, step by step. I.attack in compile time, we're going to check its static type. Static type is insect. We're going to try to find a function whose name is attack and who takes in no parameters. Well, if we go to insect, this function does not exist. And so therefore, we're going to have a compile time error. We're never going to move into runtime. All right. Now, what happens if we try to cast ant A to an ant instead? Well, once again, we have our flow chart, so let's break it down, right? And during compile time, instead of going to the static type, we're going to go to the cast type. The cast type is ant, so we're going to go here. We're going to try to find a function called attack that takes no parameters, and that function does exist right here. And so therefore, we pass compile time. Now we're in runtime. Runtime, we need to check to see if the dynamic type has an is a relationship with the cast type first. Well, the dynamic type of I is ant. And the cast type is also ant, so therefore there is a relationship. Then we're going to check to see if there's an overriding method in the dynamic type. Ant does have an overriding method. It is the same method, and so therefore we're going to print ant attacked. All right, now try to apply the knowledge to these last two remaining questions. All right, B equals new insect. Will this function work? Well, B, as we established before, has a static type of B. All right, and we are trying to create a new dynamic type, which is insect. So we ask ourselves, does insect have an is-a relationship with B? The answer is no, because remember, is-a relationship is not a two-way street. B is an insect because it extends insect, but insects are not always bees. And so therefore, this first line is going to cause a compile time error. And because this causes a compile time error, b.speak and b.move are not possible because, well, there is an error beforehand. All right, that is the broad overview of dynamic method selection. There are a few edge cases that aren't touched on in this question, so I'd recommend going and first of all, I think you should watch the video from week 5 that also goes over dynamic method selection. It covers a lot more cases, and also it covers some of the rare edge cases where you have, for example, a method whose signature is not correct, whereas different parameters, but has the same method name. So that's a very important trick to be on the lookout for. However, just as a general overview, if you understand everything that's here, you should be like 90% set for dynamic method selection questions on the quiz, on the midterm, all right? And the important parts are these 3 slides here, right? Where if you understand assignment versus initialization and the ASA relationship, you'll be good for all kinds of these questions. Then if you understand the flowchart that we use for method selection, you'll be good for those questions. And lastly, there will probably be at least like 1 or 2 casting questions on the midterm. And so as long as you understand casting and how that changes the flowchart, then you will understand how to solve those problems. Anyways, that is it for this question. Thank you very much for listening, and we'll see you in the next video.